In this session, we are going to be attempting to draw text into the window using SDL3. To draw text in SDL3, you generally have two options. Use the built-in but limited debugging functions, or use the dedicated extension library, SDL3TTF. I do want to see what this looks like, so I'll try this. However, given that it is explicitly for debug purposes, we will be going the route of SDL3TTF. I think there are some other options too, like STB font or something like this. The library processes true type files. Parse files extract glyph metrics, extract glyph shapes, render glyphs to one-channel bitmaps. So if we can render to a bitmap, then we can render the bitmap to an SDL surface, and then the surface to a texture. Because I'm already using SDL, I'm already committed to that ecosystem, we'll give this a go. I have SDL3 and I have SDL3 image, so this also might be an interesting opportunity to show how I create GI bindings for a new library. So first, I will just do the SDL render debug text stuff just to see what it looks like. Here we do game update, and then the game is going to render all of its stuff, and then to render on top of that, we don't need to be in the game logic. We can probably here just say this, SDL3, SDL render debug text, 100, 100, and the text will be, this is debug text, and then run that. This is debug text. Okay, so not gonna lie, we actually could get away with that. We could use that because we're doing like we can resize now, right? So we can blow this up. It actually doesn't even look that bad. For the full list of limitations and other useful information, see SDL render debug text, which we're just looking at. I want to see, so let's just read about this to learn about it. The function will render a string of text to an SDL renderer. Note that this is a convenience function for debugging with severe limitations. For serious text rendering, there are several good options, such as SDL-TTF, SDB true type, right? We looked at that. We should be a little more serious about this, so let's look into SDL-TTF. I want to see how many functions it has. Okay, this is not a lot of functions, and the good news is everything starts with the TTF prefix. I'll show why this is good later. It's going to help us with bindings generation. I want to look at include, probably just one file. It's two files. Text engine, interesting. Let's clone this thing, and then we'll go through the install and everything. Let's do this proper. Git submodule, add this guy, and then we will say rendered SDL TTF. In here, I have a CMake list file, rendered SDL TTF. Go into build, run CMake again on one directory up. So let's make it. Now it'll dump the binary once it builds. Here are the binaries there. So we'll link against these binaries. So now we're going to look at the bindings generator. So we'll just copy this for now. Just for the record, I forked this. I recommend it if you're using GI or if you're curious about bindings generator. So I basically took this guy right here for generate GI, for example. This has for Linux, what it requires, building bindings to and linking against the system installation of SDL3, but I build my own, not so much because I do anything special, but just because I want to build all the source or most of the source involved. I've added extensions clearly for like SDL image and whatnot. Generate bindings SDL3 TTF. This will call this, and this will call this, and then we'll just update the call site TTF. It's not going to be SDL3 image, it's going to be SDL3 TTF. As you can see here, the output file name is Linux GI, so we're not creating a module GI, so we won't be able to use this immediately, but we'll just make a very simple module. For example, the module GI for SDL3 image, if the OS is Linux, it just loads in linux.gi. Otherwise, at compile time, we just say, sorry, we don't work for your operating system yet. So when it comes time to go to Windows, I will need to fix this. So here's the header. The header is text that the bindings generator is going to insert into the generated file, SDL3TTF, SDL-TTF. So we see here that it includes SDL3 SDL.h. So it requires the base SDL library. So for that reason, we need to import the similar thing that we generate for the GI side, the SDL3 bindings. So we import that, and we don't need SDL3 image. This is going to be lib SDL3 TTF. One up, build lib SDL3 TTF. We'll leave off the suffix, the file extension. This is where we add libraries to use during bindings generation. The reason we need to use the libraries during bindings generation is because the GI bindings generator actually uses Clang to build the abstract syntax tree of the library. And this way, it's much easier to understand the different types being declared in these headers and whatnot. Like if they're aliases, we will take TTF here, TTF, lib SDL3 TTF. The include paths from the C++ side, we saw that we need SDL3. So there's SDL3, plus we actually need the include paths for what we are going to be working with, which is TTF. This is a source file. This is basically the entry point to the bindings generator. Hello world example. Here we go. We don't actually include the text engine thing. We just include SDL-TTF.h. So here we will look into, so that's SDL3 TTF and then SDL_TTF.h. So the visitor is going to be exposed to each declaration. This is is going to be SDL3 TTF visitor. Because we need to include SDL.h, like right, or SDL3 SDL.h, because we need to include that there, this visitor is actually going to be exposed to all of the definitions in these other header files as well. When dealing with SDL image, nothing from the main SDL header file has an IMG prefix. So in our case, we saw the prefix is TTF. So we will say if the declaration does not begin with TTF, then we will emit the declaration from output and we will return stop for this node. Otherwise, we recurse into the node. So it's going to do a bunch of work for SDL, then it's going to do work for SDL image, and then it will do work for SDL TTF. Here's Linux Jai. So these are macros, and they just get the string literals here. So if we look at the generated stuff, these are just compile time constants. And here, yeah, we point back up, and then build live SDL3 TTF. This is what a foreign function call looks like. So we have this function TTF was init. I can come in here and say TTF was init. So there it is, right? There's an extern TTF was init here. And in our case, we say was init returns an S32. It's a foreign call into a C library, and you're going to find the definition of the routine in live SDL3 TTF library. So now all we need to do for this guy is basically crib this from images, or SDL3 image, and we'll make a module in the SDL TTF module folder, and we will load, linux.jai. There we go. Let's go into our source main.jai. And right here, we will say SDL3 TTF is import SDL3 TTF. And we just want it to build. There we go. It builds. Now we actually need to call something to make sure that linking works. So let's go look at the hello world again. Let's just call TTF init, right? If that fails, we're hosed. After we init SDL, let's try initting TTF here. It's going to be SDL3 TTF.TTF init. Run this guy. And then we are initting the SDL TTF library. So we now have bindings for SDL3 TTF. If we want to draw something on the screen, we want to render text blended. Okay, so this actually renders text, and text is, and then from that we create a texture. Create texture from surface. I'll have to think about this from a performance perspective. If we're changing the contents of the string, then we'll need to re-render. And so we'll need to be going from surface to texture, like from text to surface to texture every single time the text changes. Ubuntu Mono. Let's get this. Let's nap this here. Mono bold, this is pretty thick. So I think we just want Ubuntu Mono regular. So let's copy this in. Let's see, I have an assets folder. In 0, we have build, we have data, entities, maps. I guess I'll make fonts, and then I'll just copy this in. We have Ubuntu Mono regular.ttf. We need to load a font in first. Initialize should load the font in. So now we want TTF open font. This is going to be font is going to be SDL3 TTF open font. It's going to be a file and a point size. So let's say font size. Maybe we'll just go with 12 for now. Path to font is toString. And then we will call string.join. And so then we just say data fonts and then this guy here. We will force the use of temp allocator there. And font size in points, not pixels. SDL3 TTF.TTF quit. Let's just guess that. And then here will be SDL3 TTF.TTF flows font. Dynamically computed strings do not cast to star U8. Only literals do. Things like a 2C string, I think. Yeah, we probably need to call it 2C string or something like this. Allocator is temp, build it again, and let's run it. So it looks like we successfully loaded the font. That's good. And we put it inside the platform. So now game has access to the font through the platform. Debug text texture is an SDL3.SDL texture. Then in initialize, we'll just add some text. Text is SDL3 TTF.TTF render text blended. We will take a platform font. We have platform here. And then we will say this is debug text, and then 0 and dot 000255 for black. And now we will set the texture. The game state dot debug text texture gets SDL3 SDL create texture from surface. This is going to be platform renderer and text. So here we would call SDL3 SDL render texture platform renderer. The texture is game state debug text texture. Source dimensions are null, so we do need to constrain the destination by the texture size of the text. Then we will populate the width and height of the destination by saying SDL3 SDL get texture size, and then we need a pointer to dest width and pointer to dest height. dest x is 100 and dest y is 100. And then we'll build and run it, and that's what it looks like. It looks pretty awful. You can render at other quality levels with TTF render text solid, TTF render text shaded, and render text LCD. Well, this is high quality. Render text blended is high quality. I just realized this is going to be a gotcha. In the previous stream, I was talking about logical screen dimensions. So what's happening here is that this text is being upscaled, I think not as like a vector or as SVG or anything like that, but it's being rendered pixel by pixel into a buffer that logically is half the width and half the height of the screen. And then it's being upscaled. It's being doubled in both directions. So we're going to get this like fuzzy font. One way, in fact, the only way I can think of right now to make this sharper, it's to read out the actual quote unquote physical destination size and render at that resolution and not do any upscaling. That will make the text super sharp. I would like to avoid that though, because the whole idea was that I write everything into the logical screen space and then I let SDL handle the upscaling and whatnot. But clearly that makes some blurry text. Control how the texture scales. Wait. Okay, I can fix this. I might want to upgrade the SDL bindings to 340 to get the pixel art scaling mode, but for now we just use SDL scale mode nearest. I can actually set this in game here, and this should actually fix the blurring. SDL3 set texture scale mode. This is just going to be GS debug text texture. It's not beautiful, and I think this is because my pixel art is what is called, at least in Sprite terms, it's called pixel perfect, which means I'm not doing any anti-aliasing. However, this font is aliased, as this says here. I was using SDL 3.4 in a previous experiment, and I didn't really see any difference between the pixel art scaling and scale mode nearest. But we could actually do that experiment right now, though. So let's go upgrade SDL3 to 340. Great, it builds, and then we will run it just to make sure we don't crash at runtime. So now we have access to the pixel art thingy. Maybe this will help us blend that better. Maybe that like does something with anti-aliasing. I have no idea. To get pixel art scaling, SDL scale mode, pixel art, and then we need to go back into game and do the same thing. See if that helps us at all. I'm gonna go with no. Oh, look at that. That's actually worse. Dang. So we are actually going to undo this change. I'm not really entirely sure what's going on with these pixel lines here, but I do know it is a consequence of the scale mode here. If I just say nearest, now this all of a sudden works much better. I mean, we don't have any of that tearing. And nearest actually, it looks fine to me. It's very Game Boy-esque. It's not actually what I was going for, but we'll keep nearest. All right, so we went on an adventure through the bindings generator and SDL versions and stuff like that. That was hopefully pretty interesting. Thanks for tuning in. I hope you guys learned some stuff. I had fun along the way, and I'll see you in the next one. Peace.